Hello everyone. Welcome to the video lectures on consistency of system. In this video lecture, I shall be giving you a brief overview of what all formulas are required for a system of equation to be consistent, and we will be seeing a PYQ example. Okay, so let us see what are this. So consistency of system, I mean that system of linear equations, that is what we are going to see. Okay, so when we have a linear equation system over here with us, so the equations are going to be something of this kind. Let's say 2x plus 3y plus 4z is equals to 5, and then you can have something like minus 2x plus 3y minus z equals to 7, then 8x minus y plus 11z is equals to 9, and then you can have something like y, or you can write here, let's say x plus y plus z is equals to 7, something like this. So this is a system of equation. Like here we have four equations in three variables. Okay, so now anything which is like this can written in terms of equations can be written in terms of matrix notation. So in this matrix notation, what we write is a coefficient. So the first column will be the coefficients of x, the second column will be the coefficients of y, 3, 3 minus 1, 1. Then the third column will be the coefficients of z. Here it will be minus 1, 11 and 1. And so what we see that this is a matrix of 4 rows and 3 columns. Okay, and then the next matrix will be the matrix of unknowns, the variables that you see x, y, z. So this is 3 rows and 1 column. And the last output will be the constant numbers on RHS that you see, that is 5, 7, 9, 7. Okay, this is the system of equation which was given to you in the equation terms. Now you have represented it in terms of the matrices. Now observe on LHS here there is this matrix order which you see that this is 4 cross 3 and this is 3 cross 1. So this number of columns of the first matrix should match with the number of rows of the second matrix. That is what is the compatibility of matrices. Only then the uh, matrix multiplication is possible. So here we have output of 4 cross 1, right? So that is what is we have learned in a matrix multiplication, and that is what is assumed to be the basic over here. Now this thing can be which we have represented here is in matrix notation is denoted by ax equal to b. Now this A matrix is called the matrix of coefficients. Okay, matrix of coefficients. Okay, the matrix capital X which you see is called matrix of unknowns. Okay, and the matrix that we see here, the B matrix, is called the matrix of constants. Matrix of constants. Now, so AX equal to B is a system. Okay, is a system of equations this system has two possibilities: either it is homogeneous or non-homogeneous depending upon the matrix B. Okay, so here there are two choices we can write like this. So if B is equal to 0, then it is a homogeneous system, and if B is not equal to 0, okay, like what you can see here in 4 cross 1, so then it is a non-homogeneous system. Non-homogeneous system. Okay, now there is something very important: the system possesses solution. Okay, a non-homogeneous system possesses a solution, rather I would say, when rank of A is equal to the rank of the augmented matrix AB. Okay, so if this is happening, it implies, this means system is consistent. Consistent. This is what is the condition. So this is what we need to remember: if rank A is equals to rank AB, then system is consistent. And if now we have something very important here. Now they say that if rank A is equal to rank AB, okay, and this is equal to the number of n, okay, then system is consistent and has unique solution. And has unique solution. Now what is this n? N is going to be, I'll put here with this color. Here n is number of unknowns. All throughout in system of equation, n is number of unknowns in Ax equal to b. Okay, if this is, then system has unique solution. Now if rank A is equal to rank of AB, and let's say it is some number r which is less than n, then system is consistent, of course. Okay, consistent, and it has infinite solutions. So these are two cases here with non-homogeneous system, and this is exactly the same what is going to happen with homogeneous system also. There is nothing much in this. Okay, now here one important thing comes, like how many number of freedom of variables we have. We can see that number of free variables, I'll write here, number of free variables, okay, for infinite number of solutions you will have are going to be n minus r. That is it. nothing more than that. Okay. Now this was regarding non-homogeneous system. Now let us see what all things are there regarding homogeneous system. Very simple, very easy, nothing uh, detailed over here, but we just need to be careful about it. Now there are few things to be noted. Okay, it is always consistent. It is always consistent. Okay, reason, it always has trivial solution. Next, non-trivial solution is possible only if rank of A is less than n. That's it. This much only is regarding the uh, homogeneous system, and we don't have to do much about it. And again, same, the number of free variable is equals to n minus r. Okay, so there is nothing much about the whole process in this, and let us see an example how to solve one of the question which was available in the examination of MU for 5 marks, and it was a compulsory question. So let us see. Here the question is, test the consistency and if possible solve. So let us write down this system of the given equations, and so let us see how to go about it. So first, write the system of in your examination. It is always good to write the given system. So we write like this: given system is 2x minus 3y 3x plus y minus 3z is equals to 13. 2x plus 19 y minus 47 z is 32. This is the given system to us. Now we write in matrix notation. We have 2 3 2 minus 3 1 19 7 minus 3 47 x y z equal to 5 13, yeah, minus 47 over here, and then 32. Okay, now this is basically, that is ax equal to b. So now see, we are removing the ambiguity of labeling the matrices. Okay, so when I write that is a equal to, that is ax equals to b, it clarifies the entire thing, that the capital matrix A is the first matrix A, x is the unknown matrix, and b is the matrix of constants. Okay, so this is the thing we have got. Now here we write down the augmented, therefore after this we write the augmented matrix is. Now the augmented matrix is basically the matrix a slash b. Okay, you just put a straight line over here, a slash b. I've just thickened up the line here. So is A slash B or A augmented with B. So we just see how to write it. So this is going to be, here it is 2 3 2 minus 3 1 19 7 minus 3 minus 47, and then you would have 5 13 and 32. That's it. This is what we have. Now we have this system here, so we want to check whether it is consistent or not. So we write here, to check for consistency, consider augmented matrix A B, okay, which is here the same matrix I'm writing again. So we consider the following augmented matrix. So now what we have to do is we want to check for the consistency. So we will be checking the criteria that we just saw, because this system is a non-homogeneous system. You can see in the RHS 5, 13 and 32, it's a non-zero matrix. So what we do, we check for the consistency by checking the rank of the augmented matrix and the rank of matrix A. So let us see how to go about it. Now, in order to find the rank, we use the definition of row echelon form. For row echelon form, or for checking of the consistency of the system, you are allowed to use only and only row transformations. Okay. So let us see how to go about it. So the what we write here is perform R1 changing to R1 minus R2. So we get here 2 minus 3 is going to be minus 1. Minus 3 minus 1 is going to be minus 4. 3 minus of minus 7 minus of minus 3 will be 10. 5 minus 13 will be minus of 8. And the other rows will remain same. Now we perform the following row operations so that we can get the rank. So perform R2 changing to R2 plus 3 times R1. Okay, because what is my goal is that I want to convert the following elements into 0. This one and this element I want to convert into 0. So what I will be doing is, with the help of A11 entry, I will be making these two elements 0. Now in this process, whatever comes in between, I won't be bothered, but I will be just focusing on making them 0. So here I will be making this R3 changing to R3 plus 2 R1. Okay, so this is what we do. Now let us perform the row transformation. So it is minus 1 minus 4 10. The first row remains unchanged. Okay, do not worry about it. So second row, these two entries have become 0. Second row and third row, oh, these entries have become 0. Now let us go about this. So R2 is 1. Okay, 1, this entry over here, and then there is plus 3 times of minus 4. So it is going to be 1 plus minus of 12, that is going to be minus 11. So here we have minus 11. Then there is minus 3 plus 3 times 10. So this is going to be 30, and this is minus of 3, that is 27. So here we have 27. Then next one is 13, and then there is plus of 3 times minus of 8. So 13 plus of minus of 24. So we have here it is 1 minus of 11. Okay. The next one, we go about it. The next is 19 plus 2 times R1, that is 2 times minus of 4. So 19 minus of 8 is 11. The next entry is minus of 47. Okay, minus of 47 plus 2 times is R1, it is 10. So that is going to be minus of 27 here. Okay, so that is minus of 27, and here it is the next is 32 plus 2 times minus of 8, that is 16. Yeah, it is going to be 16 here. Okay, so this is 16. Okay, now we go for the next operation. Perform R3 changing to R3 plus R2. We will just do this much and let's see what do we get. So here what we get is going to be minus 1 minus 4 10. The first row remains unchanged, no changes in that. Second row also now remains unchanged, 11, 27 and minus 11, no change. The third row what we see is it becomes 0 0 in the first part of the matrix, and when you do the addition of 16 and minus 11 you will get 5. This is what you get. Now we have to see what do we understand from this. So this is the part where our calculations have stopped, and now starts the analysis and the theory that we have learned. From that, the conclusions we have to derive. So what is the thing? Here we have to understand that only this much portion I'll just shade for some time, and please try to understand this. I'll highlight it. So this portion that you see, all this is matrix A. Okay, so the yellow portion which I have highlighted is matrix A, and the entire matrix that you see is the matrix AB. So when I write here for the rank of A, so the rank of A, okay, which is also denoted by this notation row A. Okay, so the rank of matrix A is basically the number of non-zero rows. Okay, so number of non-zero rows are 2. Okay, if you want, I'll write here down rank of A as per row echelon form definition is number of non-zero rows. Number of non-zero rows. Okay, so this is what here it is. Rank of A is 2. Now what we need to know is what is the rank of AB. Rank of AB, again the definition is same, that rank of AB is going to be the number of non-zero rows, but here it is 3 in that case. Now when you go for finding the rank of AB, what you have to do is that you take the entire matrix. You just for some time forget about the line that we have drawn and you consider this entire matrix. So you can see that it is 3. ओके आपको इतना याद रखना है कि ये लाइन को थोड़ा देर के लिए भूल जाइए, केवल पूरा ये मैट्रिक्स को ध्यान दीजिए, फोकस ऑन द एंटायर मैट्रिक्स, तो आपको आंसर मिल जाएगा 3. तो so here what you get is 3. Now we can see that rank of, therefore rank of A is not equal to rank of AB, hence system is inconsistent. Inconsistent. Okay, so this is what it is about. So this is how you say that it is inconsistent system. Now this much question for 5 marks is very simple and very straightforward and very scoring. Okay, it might appear that it is lengthy, but it isn't. I have just elaborately solved and given to you. I hope you have followed this. In the theory, I'll just recap the theory that what we saw, that you are given some equations, you have to write in the matrix notation. In that matrix notation you have to make it clear that it is what is capital A, what is X, what is B. So capital A is the matrix of coefficients, X is the matrix of unknowns, capital B is the matrix of constants. Now this is called the system of equation. In whatever unknowns are there, whatever number of unknowns are they are denoted by small letter n. Okay, now whether the system is homogeneous or non-homogeneous, you can just stick to the following thing, that if rank of A is equal to rank of AB, the system is consistent, otherwise not. Otherwise not, it means I'll just highlight here, put a cloud over here, that would be better. That is, let me put a cloud, that is rank A is not equal to rank AB. Rank AB, it implies system is inconsistent. Okay, that is what it means. This is the meaning. And if it is consistent, that means rank of A is equals to rank of AB, the augmented matrix, and it will have unique solution if that rank matches the number of unknowns, and if the rank is less than the number of unknowns, then you have infinite number of solutions. Now let's go a little bit to the homogeneous system. It is always consistent, it always has a trivial solution. Now let me tell you the cloud, what is trivial solution. Trivial solution meaning x equal to 0, y equal to 0, z equal to 0 is trivial solution. Okay, trivial solution. So that's the cloud for you. And then, and non-trivial solution in case of homogeneous will happen only when rank of A is less than the number of unknowns, n. Okay, so that was the thing. Here was one small example for you all. So I hope you liked it. Please hit like button, share it with your friends, those who find it useful. And this kind of questions are there all across basic mathematics till your higher standards. Till then, keep solving good amount of mathematics. Thank you.